So private and hybrid clouds, there's many different studies that are out there. I'm not going to read to you the specifics here. The point is there's a lot of interest here, and the reasons why is hopefully pretty obvious to you all. Most of you probably have some sort of data center assets or equipment that's already been purchased. You want to take advantage of that. Another key reason is that as great as public cloud resource pools are, they're not the answer for everything. And when we talk to particularly larger customers who have issues for one reason or another as to why they can't move a workload over to the public cloud, our answer is quite simply, well, don't, right? We'll set up a private cloud architecture in your data center or with your colo provider. So a lot of very healthy reasons as to why there's significant movement behind here. One of the blockers to date has been the market readiness of some of the enabling technologies that RightScale relies on. We don't integrate directly with the hypervisor, nor do we integrate directly with bare metal. So we rely on partners, but those technologies have been going through a maturation process over the past 2 or 3 years. But what's happened now is all of a sudden, in the last 6 months or so, we're seeing more and more proof points in the marketplace of these being viable technologies to deploy private cloud architectures. So Eucalyptus, a couple recent announcements. Puma, obviously, enterprise company, makes fun athletic equipment and whatnot. Plinga is one of those crazy big social gaming customers. But these are production workloads that are being run on a private Eucalyptus-based cloud. OpenStack, most of you are probably familiar with OpenStack, Rackspace open sourcing its API. The enthusiasm and the folks jumping on board to the OpenStack project, both to support it from a go-to-market standpoint as well as a development standpoint, has been extraordinary. So just look at the download mark. And it's just a great representation of the promise of what the market is really hoping for, which is you have the ability to deliver these cloud-based architectures, but some flexibility to configure and tailor to your specific needs. Another one of our key partners is Cloud.com. They tend to focus more specifically on the service provider market, and what you see here is just a small sample of the progress that they've made. So every cloud provider that you see named there is actually using Cloud.com's CloudStack technology to enable and deliver their infrastructure as a cloud service. Some of the folks from Tata are in the audience there. Their Insta-Compute Cloud is based on CloudStack. So the point in this is that the market has now changed, and these technologies are at a point where they are viable. There are production infrastructure as a service clouds that are launching using these technologies. And for RightScale, this is a critical piece of the puzzle because we rely on these enabling technologies to be able to support and automate across these various different cloud architectures. So we've been on this quest for 3 years now of stitching together multiple cloud resource pools. And before these were at the level that they are today, there was a significant challenge in doing that. So some of the other reasons, and this is what we get for answers when we ask customers what they're trying to achieve. A lot of these are probably obvious. All right, the lock-in, that's becoming very, very real, particularly as more and more of these feature sets get released that are specific to the infrastructure. We're seeing customers kind of turn away from that approach and looking for something that's a bit more uniform. Data centers, we talked about that. Geolocation is a big one. That's pretty simple in black and white. If you're consuming on Amazon right now and you have needs in Korea, they don't have a region in Korea, and there's not much you can do about that. All right, so there's a lot of good, healthy reasons as to why things are moving into this private and hybrid cloud world. But this is the goal. This is the end game. And when we talk to customers, both large and small, this is what we talk about. We simply say, hey, don't think about cloud-based architectures as a solution for a single app. Think about how you manage your entire portfolio. Because the reality is not all applications are well suited now, and some may never be well suited for cloud-based architectures. So our goal with these multi-private and hybrid cloud deployments is to give customers flexibility so that they can take their application portfolio, align it with the requirements that are unique to them, and complement what they're already doing with internal data centers, co-location, and managed services. So it's not a replacement, it's a complement. So what's feasible? I wanted to share with you just a couple customer examples of how these multi-hybrid and private cloud architectures are being consumed. This is about a year old now when we first started talking about this, but it's still got a lot of legs in terms of an interesting use case. So Eli Lilly, we're all familiar with them. They make pills that make us feel good. They had a need, which was how do we essentially enable in a self-serve way pre-configured systems, so we're not deviating from any of our compliant builds or certified stacks, but how do we enable pre-configured systems on multiple different types of resource pools. So if it's a proprietary data set that has to stay in-house and run on a private cloud, we need to put it there. If it's a public data set that can go anywhere and we just need to get it done cheaply, then it's okay to put that workload there. So they needed to create that deployment workload flexibility, but have the same level of controls and parameters that they have in their internal data center environment. So they created on RightScale what they call internally the IT vending machine. Research scientists in a self-serve way can access these pre-built certified configurations, and then they're restricted within the RightScale account in terms of what cloud resource pool they can deploy those configurations on. So it's completely controlled and all that information is reported back. The benefit to Lilly is pretty extraordinary. They took a process that used to take roughly 5 business weeks when it comes to post-procurement, right? The installation, the tweaking the conflicts, so on and so forth. The time it took to deliver that environment to the research scientists, they took it from 5 weeks down to 30 minutes. So I love this use case because it really helps to quantify what oftentimes is fairly difficult to quantify, this notion of business agility, right? So this is removing the barriers, procurement, configuration, management, so on and so forth, to delivering these systems to their internal customers. So the next real example is what happened on April 21st, and you know, I firmly believe this will be a great moment when we look back in the whole ecosystem and evolution of cloud, which was the Amazon outage in the East region. So it obviously was very significant, but what happened was they had the worst outage to date that happened in their East region, so one of their clouds. But you know, what RightScale was able to do and what customers of ours were able to do that deployed to best practices using these multi-cloud architectures is they were able to emerge relatively unscathed. And we're going to show you how this works when Josep actually does the demo. But the benefit you get is that RightScale is abstracting away the differences in these various different resource pools, right? Because even Amazon's 5 regions are all different, right? Different feature set, different image catalogs, so on and so forth. It gets even more complex when you add in Rackspace, Tata, private cloud based on Eucalyptus, private cloud based on Cloud.com. RightScale abstracts away the differences here and allows you at a platform level to access multiple different resource pools that look the same. And you can adopt a single design methodology using our server templates and have flexibility to seamlessly move, I put that in quotes because nothing is actually moving, move your resources from one cloud to another, because those server templates are dynamically configuring those systems in whatever cloud that you decide to run in using RightScale. So we came out of that disaster relatively unscathed. RightScale had a small outage on the GUI itself, but the core machinery, the automation system, the launching and orchestration and administering of servers across multiple different clouds kept on running. So pretty extraordinary event, and I think it'll serve to be very healthy and a great moment for the industry. Zynga started talking publicly about 3 weeks ago of what they call ZCloud. And ZCloud is Zynga's private cloud. As some of you may know, Zynga is a fairly large consumer of public cloud resources, a very large customer of Amazon's and very long time large customer of RightScale's. We didn't know they were going to start talking about it when they did, but we're certainly glad they did. So what Zynga has built is a private cloud they call ZCloud. And it's all managed by RightScale. But what it delivers is it gives them flexibility based on a variety of metrics that are important to them. It may be time to market, it may be cost, it may be performance, to move game workloads around. So when that game first launches, where that demand is unknown, right, you may want to launch that in the public cloud. When that usage pattern becomes more predictable, it may make sense to pull that back in and run it in ZCloud. So they were able to take ZCloud from concept to production in less than 6 months. So very, very rapid timeline. It's commodity hardware. They shared a stat, which is they're able to now provision from bare metal to a functioning resource pool in the RightScale system, 1,000 servers in less than 24 hours. Right, so pretty extraordinary timeline. And it just gives them complete flexibility on where they actually deploy these environments. So, I mean, this is an interesting moment as well. I mean, we're thrilled for this for a variety of reasons, but I think for the market as a whole, a couple myths are put to rest, right? You have the largest public cloud consumer in the world that's now running production workloads in what is arguably the largest private cloud in the world, all being orchestrated by RightScale. So this whole notion of these technologies aren't ready for production workloads, they can't scale, is put to rest. Great. So just three quick examples. So having deployment workload freedom to accelerate provisioning and configuration time, high availability and disaster recovery. We see that a lot as another common reason why customers want hybrid and private environments. And then Zynga's motivations were more around performance and cost, right? That whole market is all about the number of daily active gamers you can get on a single server. And having control over what hardware you're installing and tuning that becomes really, really important when that's the business that you're in. So with that, I want to turn it over to Josep, because the reality, as great as all these things sound, is there's lots of bodies that are buried. So he's going to take you through some of the practicalities when you're thinking about these hybrid and private cloud workloads, what to think about, what to be aware of, and we're actually going to show you some of the architectures within RightScale that are best practices.
All right, so let me start. So what I want to do is basically put some examples behind what Judge was saying. I want to start by, I want to do two things. Number one is evolve a case from a kind of simple, typical multi-tier system, evolve into multiple clouds, and kind of guide you through how you put this thing together and what are the gotchas that you may not be aware of, because these, when the things become complex across different clouds, there's certain things that you won't see until you actually get your hands dirty with it. So let's start with just defining the typical multi-tier scenario that we've talked about many times. 3 tiers: load balancers, app servers. It could be PHP, Rails, Java, whatever you're running, and then whatever backend system you have. So this is a typical deployment. Obviously, even if it's just in a single cloud, you can deploy these things in different zones to make sure that if one zone fails, you can relaunch whatever you need in the other end. And at the same time, even if it's in a single cloud, you can actually use, say, security groups or firewalling capabilities of the cloud to isolate these tiers and say, application servers can only talk to the databases through port, whatever database you're using, right? So you can use these technologies right there. So obviously, if you deploy this within RightScale, then you get the whole 9 yards: monitoring, alerting, the things that you're used to from the dashboard. Now, let's assume that you want to take this, and you're a company that has the private cloud, and it has exactly this architecture deployed in their whatever private cloud provider they use, right? So the first thing that you may want to do, if you're successful, is probably you run out of capacity. Maybe the private cloud is small enough, you've been successful in some sort of marketing campaign, you need more juice, right? What you would like to do fast probably is to burst some of this capacity out into something that you can get fast. What's faster than the public cloud? I don't know, probably nothing, right? You get your credentials, you can start launching instances immediately. So you would like to certainly start launching machines over there, but you don't want to launch them one by one. You don't want to have somebody just clicking machines as the load comes in. So you would want to kind of set them up in sort of a server array configuration, right? In which you can say, the same templates that I'm launching in these servers, just make a server array out of those, and monitor the CPU of all these application servers. And when things become too hot, start launching more. And when things are cold, kill them. So I'm going to show a demo in which we have a 3-tier architecture in a private cloud and an array set up in a public cloud. All right, so these are the pieces that correspond to the diagram. So we have here, I have a load tester machine that just generates some load, so that machines are not just sitting idle. But basically, we see here that we have 3 servers. The load balancer server, I only have one. I don't have the 2 load balancers. I have 1 load balancer, 1 application server. In this case, it's just a PHP server, and a MySQL backend, right? As you can see here, these are the templates that we have published, the multi-cloud templates that we publish that you guys can use. Okay, so that corresponds to the private cloud, and you can see here that is deployed in a cloud.com type private cloud in the same zone in this case. Okay, so then down here we have an array that I call burst to AWS that basically it's made out of the exact same template. So here we say it's PHP 5 application server template. So if I go to the array, you'll see that basically what I've done is server template is using exactly the same server template. So any instance that this array launches when it sees that the CPU is too hot is going to look like any other app server that we had in that private cloud, right? So it's going to start launching machines that way. And down here, you just configure, the policy that you want. How many instances at a time you want to scale up or down, how many minutes of calm time, and then you'll see that some instances right now. What do we have? We have 2 instances that are that are operational and taking traffic, and the original app server that it was in the private cloud. At this point, this app server is voting to grow the array, for example. That's what you could see here on the array page. But basically, the fact, if you're using the multi-cloud server templates that we provide, or if you put them together yourself, every server template will have a multi-cloud image behind, and the multi-cloud image specifies for each of the clouds which specific image you want to use. So if we take, well, we can take a look, but we'll see how far, we'll see how much time we end up taking. But if we take a look, at the app server, did I click? If we take a look at the app server, we'll see that there's this multi-cloud image, and for this particular one has chosen some CentOS 5.4 image that exists in that private cloud, right? If I take a look at the instances that are in AWS, you'll see that the MCI is the same, the multi-cloud image is the same, but the image that is picked is different. It's equivalent, but it's a different physical image. So that is solved by default by just using the same template if it's well defined across clouds. Okay? So let me move on a little bit so that we don't get stuck with this thing. But basically, the only thing that I want to show here is that this is something very easy to do if you have the right templates. And you can see, for example, here in the monitoring, that I guess you can kind of see it. There's a bit of a sinusoidal load that's coming into this application that it will go something like this, right? And the fact that at some point the CPU was too hot, a new instance was launched, a new instance became operational at this point, started taking load, right? And that's why you see that some instances come online and go offline, so they take the load off this peak. That's sort of the idea behind that. Okay, so we can drill down into as many details as you guys want from the point of view of a scenario, but I think that it may be better to try to evolve this a little bit to see some of the gotchas. So that's very easy to think about, that the fact that the same machines that are going to be launched over there, they're going to connect in the same way that they're used to connect over here. And that is true, right? You have to have a way to tell the load balancers, hey, I'm ready, start sending traffic my way. Same thing they do over here, but you can do it in many different ways. Same thing for the database. You have to say, where's the database that I need to connect to? But the tricky thing here is that these, right now, for these application servers over here, is that they have to go through the public internet. So there's 2 important things that you cannot use from your cloud provider. You cannot just say, I'm limiting this host to talk to those hosts on port 80 and nothing else. Well, that doesn't happen, right? You have to put something together, some access control across clouds yourself. The other thing is that also, even if you put the access controls, what you send through these links is open. So if that is confidential information, you may want to massage it a little bit, right? So that's something that you can do internally here, but you cannot do across clouds, right? These security groups and access controls are not shared across clouds. So that's the tricky thing there. Now, the next thing that we may want to do is to say, well, what if we want to distribute the databases? You can put one more slave in this particular private cloud, but you can also think about moving that slave into the public cloud in terms of a DR situation. that's really, really, really easy, right? As I explained before, you use the same template, you create a new server that points to the other cloud, you start it, and you have a new slave up and running in no time. And you have to solve the same encryption and access control mechanism, and sure, great, it's very easy. Now, is it? Because where is the data? I can have a server running in no time, but where is it going to get the data, right? So suddenly, here we're very used to, oh, I'm putting up a new slave, I have some snapshots that I have here, I create a volume from those snapshots, the data is up and running, it's going to be a little slow at the beginning, but I have the data. It's a fast backup recovery thing. But when you're over there, the data, you can not use this backup, right? So then you have to solve this problem, and this is quite a complex problem when you go in multi-cloud, because you can do simple things like, my backups here, other than just snapshots, I may want to save them to S3 or cloud files, right? And then in that way, that slave over there can actually restore from S3 or cloud files, and that works well. Except if you have a terabyte database, you better know how to entertain yourself while the backup is being restored, because it's again, it's like it's going through the public internet with all these problems that you're actually facing. So the data, since there's no data sharing across clouds, these situations become quite tricky, and that's something that RightScale can help in some ways, but at the end of the day, it's something very specific to your application. We don't know how to move the data that you need, and there's going to be things that are going to put in place to make it easier for you guys, but this is a complicated thing to solve, right? You can have snapshots here and there, you can have live replicas of the data so that it's much easier to recover the deltas from one side to the other. You can do a lot of things, or maybe you don't even have a relational database and you're already using something that is distributed in nature, right? So that's a tricky piece. And I guess the last piece from this simple example that you could think of moving out is the load balancer. Say you could move one of the load balancer boxes there, and nothing really changes much. Again, you create a new server with the same template, and you change the DNS to round robin across 2 different IPs, and we're good. Right? Maybe there's a tricky thing in like, now these application servers need to know about that one, those application servers need to know about this load balancer. You have to be a little tricky about, careful about how you contact them, but it's essentially the same. So with the time that we have right now, that's basically what I kind of wanted to sort of cover. And there's a lot of more nooks and crannies here that you actually have to solve for realistic operations, but hopefully you get a little bit of a feel of some of these things.
Hopefully you get the message now. This is real. This is no longer just a hype. This is no longer just something that we're dreaming of. There are actual production hybrid cloud workloads that are quite substantial in size that are deployed today. The reality is you can deploy these things on commodity hardware. There's multiple hypervisor support that's available. And then what the MyCloud product is all about that launched and was announced yesterday is to make it really simple, really cheap, and really fast to get started. So a couple more specifics on that. It's currently available on both cloud.com and Eucalyptus. There's going to be a completely free version of the MyCloud product, as well as a very cost-effective $500 a month standard version, and then you can customize until your heart's content on the enterprise version. Part of the free and the standard, part of the goal there is that we wanted to enable companies a very easy way to start to develop proof of concepts and test out different workloads. One of the challenges that we faced at RightScale early on when we first launched this program with Canonical and Eucalyptus several years ago is we had great success in a lot of clouds registering with our dashboard. We had no success in actually delivering any production workloads to our customers on those clouds. And the reason is because the variance of those resource pools was dramatic. Right? Customers were doing, you name it, they were doing it as far as different configurations of how they'd set up their Eucalyptus cloud in this particular case. And because, as you all know, our way that we deliver value to customers is all around the server templates and right image configuration, if we don't have some understood set of parameters in terms of what that cloud looks like, there's very little we can do with it. So we spent a lot of time over the past 18 months co-developing with Eucalyptus and cloud.com a defined set of parameters. So on the MyCloud Eucalyptus version, for example, the download includes Zen. It includes Eucalyptus. It includes a base write image, our CentOS 5.4 write image. It's an integrated registration and activation path that in a matter of minutes you can get a working workload up, a working cloud resource pool up and running in RightScale. But then more importantly, we know what specific server templates are ready to run on that cloud. So very quick, very easy. And then you have further variances that are at your disposal once you move up in versions. So if you want to introduce VLANs instead of flat networking, free to do that, fully supported by RightScale, but it just falls out of that tightly defined set of parameters. So really all you need is a couple boxes to try this thing out. Really encourage you guys to all do it, and let us know what you find, and let us know what type of workloads make sense, and then we can take things from there. But very easy way to get started.